Hi guys, today we're gonna go ahead be solving linear inequalities in a single variable. Okay, so what is a linear inequality? And an inequality, a linear inequality is a statement that has any of the four following symbols. So we have is greater than or equal to, is less than, or is less than or equal to. So pretty much back in the day we were solving equations, but now we're too cool. So we're going to go ahead, spice it up, and we're going to replace the equal sign with the inequality symbol, like say x plus 1 is greater than 3. Okay, so the question is, how do we solve inequalities in a single variable? To solve them, you are going to solve them the same way you were to solve an equation. So your main objective is to isolate that variable. So in this case, to do an addition by 1, let's go ahead, subtract 1 from both sides, and that will give us x is greater than 2. Okay, now in your first year algebra course, we would just solve the inequality and then we're good. But now that we're in the second year of algebra, we want to take it a step further. Not only do we want to solve them, but we want to write the answer in interval notation. Okay, so before I go into interval notation, let me go back to my fun problem. So again, to solve inequality, you're going to use the same steps as you were solving equations. The one catch is that at any time that you have to multiply or divide by a negative, you have to flip the inequality. So let's just say if I had negative x plus 1 is greater than or equal to 3. I just spice it up for fun. Okay, so to isolate that variable, to undo an addition, let's go ahead, subtract, and that will give us negative x is greater than or equal to 2. Okay, to finish it off, to get rid of the times negative 1, let's go ahead, divide both sides by negative 1. And for me, bringing down the rest of the problem, I want to write x is greater than or equal to negative 2. Okay, but this is the thing, again, when it comes to solving inequalities, at any time, if you have to multiply or divide both sides by a negative, you have to reverse the direction of the inequality symbol, or in short, we gotta flip it. Okay, so we have to flip it, and our statement should read is less than or equal to, x is less than or equal to negative 2. But the question is, why is it that we have to flip it? So to illustrate that, I'm gonna to explain that, I'm gonna explain with examples. Okay, so let's just go ahead, compare some numbers. So let's just say that I'm comparing 2 to 4. Okay, so I know that you know that 2 is smaller, so if I insert an inequality symbol, my statement should read 2 is less than 4. Cool. Now, for some reason, don't know why, I feel like multiplying both sides by negative 3. Okay, why? Because I felt like it. Okay, so when we multiply both sides by negative 3, that will give us negative 6, and then will give us negative 12. And being the good students that we are, we're like, oh, we gotta bring down the rest of the problem, which is less than, which is less than. So we have negative 6 is less than negative 12, but this makes me upset because negative 6 is not less than negative 12. It's actually larger or greater than. Okay, so there's no way around it. To make this a true statement, we have to reverse or flip the direction or flip the inequality. Okay, yeah. Now, when I'm comparing two numbers, it's very easy for me to see, like, oh yeah, we gotta change it so it makes sense. But when there's a variable involved, it makes sense to me either way. So this is just gonna have to be something that you have in the back of your mind. At any point, if you multiply or divide by a negative, you have to flip it. Cool. So again, the main objective of this section is to solve inequalities in a single variable, but we're gonna take it a step further. We're gonna write our answers and express them in interval notation. But now the question is, what is interval notation? So sorry, an interval of real numbers, what is that? Let me go ahead, highlight it. An interval of real numbers is a set of real numbers that lie between these two other numbers. Okay, so pretty much I have a number here and I have a number here. Those are the endpoints, and then I want to identify all the real numbers in between them. Okay, so interval notation always goes from left to right. That's how we read. Now for interval notation, sometimes we're gonna put parentheses, or sometimes we're gonna put a bracket around the endpoints. The question is, which one do we use? So if the endpoint is included, then we're gonna go ahead and use a bracket. If the endpoint is excluded or not included, then we're gonna go ahead and use parentheses. Okay, let me go ahead and zoom this in. Okay, so when we read this statement from left to right, this reads -1 is less than x, and x is less than or equal to 2. Okay, so let me go ahead and write this. Okay, from the variable, the first part, what needs to happen? X has to be greater than -1, and at the same time, x has to be less than or equal to 2. So I'm going to write x is greater than -1, and x is less than or equal to 2. Okay, so we want to graph all the numbers that are bigger than -1 and at the same time are at most 2. Okay, so first I'm going to go ahead and highlight if the endpoints are included. So looking at -1, the inequality does not have what I call the equal to part. I don't want to call it the equal sign, because the equal sign, you know, we have two horizontal lines. Okay, I want to call it equal to part. Because the inequality symbol does not contain the equal to part, -1 is not part of the solution. So we're gonna fake graph it with the fake point. Okay, my points when I graph, I go like this, and then my fake points, I'll just go like that, or like the world tells it, close circle, open circle. Okay, so -1 is not part of the solution, so we have to fake graph it with our fake point or open circle. Call it however you like. Now, depending on the book that you're using, they may go straight to parentheses. So bracket if you're in, parentheses if you're out. I myself don't like to use brackets and parentheses when I graph, because I have to remember that the bracket and parentheses, yeah, you can't see it, didn't look nice. The bracket and parentheses need to open to where the actual solutions are. So I like open and close circles. Okay, but you do you. Okay. Now, what about the endpoint at 2? So we have x is less than or equal to 2. So because the inequality symbol has the equal to part, then 2 is part of the solution. So we can graph it. How do we graph numbers on the number line? We make a point. That's it. Okay. Graph it if you're in, fake graph it if you're out, or close circle if you're in, open circle if you're out. So we have established what's going on with the endpoints. Now, what about the rest of the solutions? We want to graph the numbers that are greater than -1, and at the same time, they have to be less than or equal to 2. Numbers that are greater than -1 are going to be to the right, and then numbers that are, or values that are less than 2, are going to be to the left. So altogether, the numbers that are greater than -1 and less than or equal to 2 are these numbers right here. I'm not sure if you can see my graph, so what I'm going to do, I'm just going to do squigglies. Yeah, you understood me. But now, how do we write this in interval notation? So we want to highlight all the numbers that are greater than -1 and at most 2. So interval notation always goes from left to right. So you want to tell the reader, hey reader, we have all the real numbers that start here and end there. So in interval notation, we have the interval from, we start at -1 and we end at +2. Okay, so the interval is between -1 and 2. Now, what about the endpoints? Are they included, are they excluded, or just one is in? -1 is not part of the solution, hence the open circle. So let's go ahead and put parentheses. Okay, 2 is graphed, so 2 is part of the solution. So we're gonna go ahead and put brackets. So again, brackets if you're in, parentheses if you're out. Fantastic. Let's go ahead and look at this next problem. So we have x is greater than or equal to 2. So first of all, let's go ahead and make the call if 2 is part of the solution. The inequality symbol has what I call the equal to part, so we can graph it. So we have graphed one solution. Now we want to graph the rest of the solutions, and these are the values that are larger. So 3 is larger, 4 is larger, so we're going to pull to the right. Now, how do I express all these numbers in interval notation? So interval notation goes from left to right. We want to tell the reader, we start here and we end there. So we start at 2, and new to our life, we end nowhere. But we're going towards the positive direction, so we're going to say that it's the interval from 2 to infinity. Okay, so we have established the endpoints. Now, what are they in or are they out? 2 is graph, so it's part of the solution, so we'll put brackets. Now, this is the thing. When it comes to infinities, whether they're positive or negative, because the infinities don't represent specific numbers, they are always going to get parentheses. Okay, so in interval notation, we graph the numbers from 2 to infinity where 2 is included. There's no need to say where infinities are excluded. Okay, next one, I'm trying to cover all the case scenarios that you're going to see in this section and in this course. We have x is less than or equal to 2, so same speech. Make the call to see if the endpoint is part of the solution or not. Inequality symbol has the equal to part, so 2 is part of the solution. The rest of the solutions are the values that are less than 2, so we're going to pull to the left. 1 is smaller, 0 is smaller. In interval notation goes from left to right. We graph the numbers that start here and end there. So we start at nowhere, but we're coming from the negative side, so it's going to be the interval from negative infinity to 2. So we graph the numbers from negative infinity to 2, where 2 is included. So remember, infinities, whether positive or negative, always get parentheses because they don't represent specific numbers. And that other endpoint, well, it's graph, so it's a bracket. So remember, brackets if you're in, parenthesis if you're out. Okay, we have ¿cuántos más? 3 more. Sorry, my Spanish gets in there. Alright, so we have x is greater than negative 1. So in this case, x is strictly greater than 1. So negative 1 is not part of the solution, so we don't have the equal to part. So we can't graph it, so we have to fake graph it. Okay, the values that are larger, 0, 1, 2. So let's go ahead, pull to the right. So in interval notation, we start here and end there. We start at negative 1 and pull towards the positive direction. So in interval notation, we graphed all the real numbers from negative 1 to infinity, where negative 1 is excluded, so parentheses. Okay, almost grand finale. We have x is less than negative 1. So again, first things first, is this bad boy part of the solution? There is no equal to part, so negative 1 is not part of the solution, so we're going to fake graph it with our fake point open circle. The actual solutions are the values that are smaller, so we're going to go ahead, pull to the left, namely towards negative 2 and negative 3. And in interval notation, what did we graph? We graphed all the real numbers that start here and end there. They start nowhere, but they're coming from the negative side. So it's going to be from negative infinity to negative 1, where negative 1 is excluded. So parentheses. Fantastic. Grand finale. Okay. So we have x is less than negative 1 or x is greater than or equal to 2. Okay, the difference between and or. Okay, if we have an and, whatever you grab has to satisfy both inequalities. Okay, so it has to be bigger than this and less than that. Or, as long as you satisfy either one, you're good. Okay, so let's just go ahead, graph them one at a time. First part of the puzzle, x is less than negative 1. So once again, negative 1 is out. And the actual solutions are smaller, so we're going to pull to the left. Okay, second part of the puzzle, x is greater than or equal to 2. So 2 is part of the solution. And additional solutions are larger, so we're going to pull to the right. I'm going to go ahead and write this over here because I don't have space. So how do I write this in interval notation? So interval notation goes from left to right. So we graphed all the real numbers that start here, took a pause, continued here, and then ended there. See, that pause action doesn't really work with interval notation. So in this case, we have 2 separate pieces per se. So we're going to have 2 separate intervals. So 1 interval for each piece. So first part of the puzzle, the interval, we start nowhere, but we're coming from the negative side. So it's going to be from negative infinity to negative 1, where negative 1 is out. Or second interval, we start at 2 and we pull towards positive infinity. Now, and then 2 is included, sorry, bracket. Now, I understand myself, but this is how it's going to go down. We wrote the word I wrote the word or because I'm just copying it down. But when it comes to expressing the solutions in interval notation, if you have more than one interval, the word or doesn't fly. You're going to have to replace it with the union symbol. Okay. Okay, so we have the union of these two intervals. Okay, so it's just like a U. Okay, so we have the union of these two intervals, and this is what I would like to see. Okay, if you don't have an interval notation, then you write the word, and if you have interval notation, you write the union symbol. Fantastic. So this is how it's going to go down. So again, the primary objective of today's speech or talk is to solve linear inequalities in a single variable, but we are going to be expressing all our solutions in interval notation, so we needed to get that out of the way. Let me find my sheet of paper and then we'll continue. Alright guys, so let's go ahead and wrap up this section. So we are going to wrap up this section by doing 4 problems. I'm going to give you some inequalities. I'm going to ask you to solve them, and then I'm going to ask you to express the answer in interval notation. So when you solve a problem, make sure you write it in the using the notation that's being asked. So in this case, it's interval notation. So again, gentle reminder, to solve inequalities, you're going to solve them like if they were equations. Your ultimate goal is to isolate that desired variable. The one catch is that at any point, if you multiply or divide by a negative, you got to flip the inequality symbol. So let's do this. So if I was going to do this without the use of a calculator, I think I would wipe out the decimals, but you guys have a calculator, so let's just keep them. Okay, so to isolate the variable term, to undo a subtraction, let's go ahead, add 0.12 to both sides, and that will leave us with negative 2.5x is less than or equal to 1.25. Fantastic. To finish it off, to get rid of the times negative 2.5, let's go ahead, divide both sides by negative 2.5. So I know that you know that whenever you multiply or divide by a negative, you gotta reverse the direction of the inequality symbol. So you're gonna hear me say, let's bust out the sirens. I want to make a big fuss on paper because I'm hoping that when I look at my notes to prepare for a quiz, a test, or even just to do my homework, I'm hoping that if I write my thoughts on paper, it will remind me like, oh yeah, don't forget, if you multiply or divide by a negative, flip this bad boy. Okay, so the negative 2.5's cancel, and that will leave us with x. We gotta flip it. It should now read is greater than or equal to whatever this quotient is, which I think calculator says negative 0.5. So I want to box this and move on. So we solved it. Okay, we've isolated the variable, but the thing is, we need to write the answer in interval notation. Cool. So I want to point out that nowhere in the directions does it say that we have to graph it, but for me, for me, if I ever have to express an inequality using interval notation, I will always graph it because I need it. Okay, so we're gonna go ahead, bust out a number line. Right now it's a line, but as soon as you highlight a number on it, bam, number line. Okay, so you can write down all the numbers that you like, but for me personally, I only highlight the number that's being compared to the variable, which is negative 0.5. If for you, you would like to put additional numbers, like numbers that are before and after, so like I guess after will be 0 and then before negative 1. Do what you gotta do. Okay, first things first, make the call if that endpoint is part of the solution. Inequality symbol does have the equal to part, so that negative 0.5 is in. Let's go ahead and graph it. The additional solutions are the numbers that are greater than negative 0.5. So like 0, 1, 2, 3. So we're gonna pull to the right. So I was a little iffy going straight to interval notation, but thanks to our graph for fake extra credit, with confidence we're gonna write down the answer. So interval notation goes from left to right. So we start at negative 0.5. and then pull towards the positive direction. So it's the interval from negative 0.5 to infinity, where negative 0.5 is included, which is code for brackets. So that is our answer. Okay, so we have a total of 4 problems. Let's go ahead and knock out the next one. Problem B. Okay, so problem B, we have 6 is less than 3x over negative 4. 6 is less than 3x over negative 4. Okay, so first things first, let's go work our magic to isolate that desired variable. But this fraction is getting in my way, so let's get rid of it. So to get rid of the division by negative 4, let's go ahead multiply both sides by negative 4. And like you said it, let's go ahead bust out the sirens. Okay, at any point, if we multiply or divide both sides by a negative, we have to reverse the direction of the inequality symbol. That takes forever to write, so I'm just going to say flip. Okay, so we should have negative 24 now is greater than, because we got to flip it, is greater than 3x. Fantastic. Work your magic. Knock it out. Okay, so to get rid of the times 3, let's go ahead divide both sides by 3. There is no flipping. Sometimes students get nervous and they're like, oh my goodness, because that's how we speak. It's like, oh my goodness, we divided, there's a negative, let's flip again. But no, my friend, we didn't divide by a negative, so there's no flipping. Okay, so let's do this. So we have negative 8 is greater than x. Desired variable is isolated. You're good. If you feel comfortable to write your answer in interval notation, go for it. You know I don't. Okay, you know that I have to graph. But for me, I don't feel comfortable. I don't feel confident graphing it. I could read it. Negative 8 is greater than x. But when I read it like that, when I don't read it from the variable, I don't have a sense of what the solution is. So what I'm gonna do, let me go ahead put optional. Okay, I'm gonna go ahead rewrite as. Okay, so we're gonna rewrite it, which means write it again. Okay, flip, you're changing the meaning. Okay, but when we rewrite it, we're gonna write it again. It's gonna look different, but it's gonna keep the same meaning. When we read this from the variable, this reads x is less than negative 8. So let's go ahead write that. What was it again? X is less than negative 8. Now, if you're having a moment and you think you're gonna write it wrong, well, bust out the SOS card. Write down the x, write down the negative 8. Inequality is currently pointing to, on the top, inequality points to x. So when you rewrite it, it should still point to x if now we're having issues. Okay, so do it however you can. Bust out the SOS card or generally read it. Either way, no one's gonna know. Okay, so with confidence, let's go ahead graph this on the number line to help us to write it in interval notation. So let's go ahead locate negative 8 on the number line and then make the call. Is this endpoint part of the solution? There is no equal to part, so negative 8 is not part of the solution. Let's go ahead do an open circle. The actual solutions are the values that are less than negative 8. So we're going to pull towards negative 9, negative 10, or to the left. With confidence, interval notation goes from left to right. So we're going to start here, nowhere, but we're coming from the negative side. So we're coming from negative infinity and we're stopping at negative 8. So the solution is the interval given from negative infinity to negative 8, where negative 8 is excluded. So parentheses. So remember, brackets if you're in, parentheses if you're out. So don't forget, guys, pause and rewind as many times as needed. Let's go ahead we're doing a total of 4 problems. So let me go ahead do an arrow. Because when I look at my notes, it's always nice if I know where to look at next. Oh, which brings me to a good point, guys. As you guys take your quizzes and tests, if you have to start a new column, yeah, please use an arrow. I have to know where to read next. If I don't, then I'm sorry. Okay, so we have negative 4, open parenthesis, 2x minus 5. Close parenthesis is greater than or equal to 2, open parenthesis, 6 minus 4x, close parenthesis. Okay, so this is blended a little bit too much. Sorry. Okay, let's do this. So again, simplify each side and then fix it so we have the variable terms on one side. So on the left side, when we distribute, product of negative 4 and 2x will give us negative 8x. Product of negative 4, negative 5 is 20, and that should be greater than or equal to 2 times 6 is 12, and 2 times negative 4x is negative 8x. And this is where me and your book fight. Well, not literally, that's just how I speak. Your book gives a problem, well, not similar to this, but it gives a statement similar to this, and then they say, bam, this is my answer, or quick, what's the answer? But this is a lot for me because I'm trained to fix it so you have variables on one side and non-variable terms on the other. So for me, I'm not going to lose that train of thought. So we have x's on both sides. It's the same x, so you pick one. Whichever one you pick, it doesn't matter. Okay, whether you say you move the x on the left or the right, we're both going to write the same thing. Okay, so after you add 8x to both sides, then that will leave you with 20 is greater than or equal to 12. And am I having a moment? Of course I am. Okay, because I'm so used to like having the x. But the first day of class, we had a problem where like the variables canceled out. So whether you have an equation or inequality, if the variables cancel out, I need you to stop there. We're not solving for 20, or so there's no like minus 20 to both sides. We're not solving for 12, so no minus 12 to both sides. I mean, if you do, I mean, it's fine. It's just you're taking unnecessary steps. If you're solving an equation or inequality, and if the variables cancel out, I need you to pause it and then ask yourself, is this a true or false statement? Again, I don't need this for credit, but I love speaking to myself. I'm like, I don't know, is it a true or false statement? So our statement reads 20 is greater than or equal to 12. So I'm like, well, is 20 greater than or equal to 12? Yeah, 20 is bigger. So this is a true statement. So the moral of the story from back in the day, if the variables cancel out and we end up with a true statement, then that means that the equation, the inequality has the solution set of all real numbers. Now, what if we had a false statement? Then there's no solution. Okay, all real numbers is not in interval notation. Okay, if you're like, anonymous Torres, I know how to write this in interval notation, go for it, but I don't. So we have a line. Okay, we highlight any number on it. Some of you may want to highlight 20. Some of you may want to highlight 12. Some of you may want to highlight your favorite number, 7. But for me, I know that I'm going to graph the entire number line, so I'll just put 0. Okay, and we're graphing the entire number line. So the moral of this story is that in interval notation, the set of real numbers is given by the interval from negative to positive infinity. Cool. So I told you that we were going to do 4 problems. This is our 3rd problem. Let's go ahead and knock out our 4th and final problem because we need to go. Problem D. We have 6 minus open parenthesis 5 minus 3x close parenthesis is less than 7x minus 3 minus 4x. Fantastic. So let's go ahead and clean this up. So we have 6, and then we're going to go ahead take care of the subtraction sign by adding the opposite, distribute the negative, put a 1 in front. No matter how you say it, we're all going to get the same response. When we take care of the subtraction sign, adding the opposite of 5 is negative 5. Opposite of subtracting 3x is adding 3x. Again, you can just say, distribute the negative. On the right side, there's no grouping symbols, but we can definitely combine some of these. So 7x minus 4x is 3x. We bring down the rest of the problem. On the left side, it's not quite simplified, but we got this. We only have one variable term. Fantastic. And when we combine the constant terms, 6 less 5 will give us 1. And that should be that should be less than 3x minus 3. And again, same speech. Me and your book fight because your book expects for you to spit out the answer. But to me, I'm like, well, that's like a premature question because I don't have the x's on the same side. So I'm going to keep going with the flow. So you move one of these variable terms, whether you say we're going to move the one on the left or the right, we're both going to write minus 3x. So the x's cancel on one side as expected, but what I did not want to expect is that the x's canceled on the other side as well. So when the variables cancel out, take a pause right here. Don't subtract 1, don't add 3. If you do, that's fine because that's not your answer anyways. So variables cancel out, equation or inequality. I need you to pause it and ask yourself, is this a true or false statement? Well, last time I checked, well, I have to read it. Okay, so it reads 1 is less than negative 3. Now, continue. Last time I checked, 1 is not less than negative 3. It's actually larger. Okay, so the moral of the story is that if the variables cancel out and you end up with the false statement, then the inequality, or if we had an equation, has no solution. And now I'm like, okay, well, how do I write no solution in interval notation? You can't, okay? Why not? Okay, so let me go ahead and do a number line. So it's just a line and we highlight any number on it. Okay, what is the solution? There isn't any. If there's not a solution, there's nothing to graph. If there's nothing to graph, then we cannot tell the world, okay, we graphed all the real numbers that start here and end there. Okay, so that's why there's no interval notation when we have no solution. Okay guys, so I said we were gonna do 4 problems. That was our fourth and final problem, so I think we're good. Gracias.